Excuse me, I'd like to monitor things going on around my house and experiment with some automation projects.
You've come to the right place. What you need is a Kamakuza 3500. It's got an 8-core processor with 32GB of RAM, a 4TB hard drive, chrome-plated grease nipples, and double reverse overhead twin-cam door handles. A steal at $1,995.
Well, $2,000 is a lot of money. Would you have something a bit cheaper?
Well, you could economize slightly. How about a Raspberry Pi 4? Ethernet, Wi-Fi, 4 USB connectors, plenty of I/O ports, and dual 4K video, all for around $100.
I like the I/O ports, but I don't really need something that I can use as a desktop.
How about a Raspberry Pi Zero? It's an ultra-compact board with an ARM processor and 512 megabytes of SD RAM. Runs Raspberry Pi OS, all for about $22.
I think that we're getting closer. I really don't need the flexibility of an operating system. And do you have something with the ability to input analog signals directly?
Ah, a discerning customer. Could I interest you in a Raspberry Pi Pico? All the GPIO you could ever want, including 3 analog inputs, and you program in MicroPython to get the most out of the device. Only $8.
Wi-Fi?
Okay. The Raspberry Pi Pico W then. All the goodness of the Pico, but with Wi-Fi and 1-day Bluetooth. $12 and it's yours.
That sounds perfect. Wait, what? 1-day Bluetooth?
It's a long story. Just take the board.
So what can I do with this device?
Well, how about you check out a copy of the book Raspberry Pi Pico Tips and Tricks. That will get you started and show you how to connect it to a wide range of devices and sensors.
How much is that going to cost?
Actually, you pay whatever you want, including nothing. The link is in the description. We'll go through getting the hardware and firmware set up and connecting to our computer for programming using Thonny and MicroPython. Then we will get practical and blink the onboard LED. I know, right? Amazing stuff. We'll check out switches that we can use to recognize a change in the physical environment. We'll control servos, DC motors and stepper motors and introduce physical movement into our repertoire. We will measure distance with a time of flight sensor and determine temperature in 3 different ways. We will display information on a small traditional screen as well as on a display matrix and some addressable LEDs. We will detect motion with a PIR, the presence of different gases, and vibration. We'll add an SD card to provide access to external storage and connect an inertial motion unit to determine orientation. Lastly, we'll integrate the readings that we get from the Pico into a wider monitoring and alerting stack with Prometheus and Grafana. Of course, that isn't all. The book is a living thing. It will continue to grow as different opportunities to measure and control our environment present themselves. Follow the link in the description to Leanpub and enjoy the experience of learning about the Raspberry Pi Pico.